Hello students, welcome to another session of this inverse trigonometric functions. In this session, we are dealing with properties of inverse trigonometric functions. So there are plenty of properties must be known to everyone. So let's prove them. So here are first three properties. Okay, I'll be giving in a bunch of three properties. So here is the first bunch, that is sine inverse of 1 by x is always equals to cos inverse of x provided x must be greater than or equals to 1 or x must be less than or equals to 1. So better you remember this. Sine inverse of 1 by x is equals to cosec inverse x. Similarly, cos inverse of 1 by x is equals to sec inverse x, and tan inverse of 1 by x is equals to cot inverse of x. So please note down this and I will be proving all these properties. Okay, so better have screenshot of this, and after every page fill you pause the video and make your notes. So this is my request. So here is the first property. To prove sine inverse of 1 by x is equals to cosec inverse. So what you have to do is you have to take this cosec inverse x as y. Okay, so consider cosec inverse x is equals to y. Then x is equals to what? As I told in the last class, if cosec inverse x is equals to y, then x is equals to cosec y. Okay, so x is equals to cosec y. Then take reciprocal it. Okay, so taking reciprocal of it, what we will get? 1 by x is equals to 1 by cosec y. Just reverse. Okay, so then you know that 1 by cosec is what? 1 by cosec is sine. So I can write 1 by x is equals to sine y. So 1 by x is equals to sine y. Then you can write it 1 by x equal to sine y means y is equal to sine inverse of 1 by x. Okay, so as we know that if x is equal to sine y, then y is sine inverse x. In the same way, if 1 by x is equal to sine y, then y is sine inverse of 1 by x. So now you replace your y. Y you have taken? Y is cosec inverse x. So just replace this y by cosec inverse x. So that's your result. So remember, sine inverse of 1 by x is cosec inverse of x. Okay, so similarly we can prove remaining two properties. To prove cos inverse of 1 by x is equals to sec inverse of x. So consider this as a y. So consider sec inverse of x is equals to y. Then what x implies? X is equals to sec y as earlier. Take reciprocal of this. If you take reciprocal, so 1 by x is equals to 1 by secant y. And 1 by secant y is, it is cos. So this is replaced by cos y. Okay. So I will write 1 by x is equals to cos y. And as usual, what y stands for? Y is equal to, if we transfer cos this side, it becomes cos inverse we write. So we can write it as a cos inverse of 1 by x is equals to y. So y is what? Y is secant inverse x. So replace here. So that's the thing. Very easily you can prove this. Similarly, we will have for tan inverse 1 by x. Okay. So this is the third property, that is tan inverse of 1 by x is equals to cot inverse x for all x greater than or equals to 0. Okay. As usual, consider this as a y. Very simply you can prove. Consider cot inverse x equals to y. Then as usual, x is equals to cot y you can write. So this implies x equals to cot y. Then as earlier, take the reciprocal. If you are taking reciprocal, you will get 1 by x is equals to 1 by cot y. So as we know that 1 by cot is tan. So it is tan y. So 1 by x is equals to tan y means y is equal to tan inverse of 1 by x. Okay. Now you replace y is what? You replace y as this cot inverse x. So This is the result. Tan inverse of 1 by x is cot inverse x. So do remember all these properties. Okay. So next I will be bringing another bunch of 3 properties. Okay. So this is second bunch of properties. Sine inverse of minus x is minus sine inverse x. Tan inverse of minus x is minus tan inverse x. And cosec inverse of minus x is minus cosec inverse x. So please do remember this before proving. Okay. So look here, in case of sine inverse, tan inverse, cosec inverse, if you have negatives x, then that negative comes outside. Okay, you can write minus sine inverse x, minus tan inverse x, minus cosec inverse x. So we will be proving one by one. Okay. So here is the first one, that is to prove sine inverse of minus x is minus sine inverse x. Okay. So as usual, consider this. Consider sine inverse of minus x is equals to some y. So consider sine inverse of minus x is equals to y. Then what about then minus sine x? So this is minus x. This implies minus x is equal to sine y. Okay. So sine inverse of minus x equal to y means you can write minus x is equal to sine y. Okay. Now you transfer or multiply both sides by minus, or you can transfer this minus side this side. So x is equal to minus sine y it becomes. If you multiply both sides by minus, this side it becomes plus and this side you will get minus. Okay. Now as we all know that sine of minus theta is, we know that this minus sine theta is equals to sine of minus theta. Okay, as we know this, sine of minus theta is minus sine theta. So that is the reason this minus sine y can be written as sine of minus y. So this minus sine y is written as sine of minus y. Okay, now you can transfer or take inverse on both sides. So what you will get? Sine inverse of x is equals to minus y. Okay. As we know that if x is equals to sine y, then y is sine inverse x. In the same way, okay, x is equal to sine of minus y. So minus y is sine inverse of x. Okay. Now you replace your y. What is y? Your y is, or you can write here, y is transfer this minus sign this side. So it becomes y is equal to minus of sine inverse x. Okay. Now what is your y? Your y is this. So replace here in place of y. So you will get sine inverse of minus x is equal to this as it is. Okay. So very easily you can prove this. So this must be known to you. Sine of minus theta is minus sine theta. So similarly in case of tan and cosec. Okay. Let's prove the second one. To prove tan inverse of minus x is minus tan inverse x for all x belongs to R. Okay. So as usual, take this as y. So let us consider tan inverse of minus x is equal to y. Then what does it imply? Minus x is equals to tan y you have to write. And both sides multiply by minus 1. So what will get? X is equals to minus tan y you will get. X is equals to minus tan y. And as I said earlier, minus, see remember this, minus tan theta can be written as tan of minus theta. Okay, so minus tan theta is tan of minus theta. So using this, you have to write this minus tan y as tan of minus y. Minus tan y is written as tan of minus y. Now you can write minus y is equal to tan inverse of x. Okay, so this implies tan inverse of x is equals to minus y. Okay. Now y is equal to minus tan inverse x. Multiply by both side by minus. So we will get y is equal to minus tan inverse x. Fine. Now what is y? Y is your tan inverse of minus x. So replace here, you will get tan inverse of minus x is minus tan inverse x. So very easily you can prove this. So note down this. Let's have another property, that is for cosec inverse minus x. So to prove cosec inverse of minus x is equal to minus cosec inverse x, so consider as usual this as y. Okay, so consider cosec inverse of minus x is equals to y, and as usual minus x is equal to cosec y it becomes. Now multiply both sides by minus 1. So if you multiply both sides by minus 1, this side it becomes x and this side it becomes minus cosec y. Okay. Now minus cosec theta can be written as cosec of minus theta. As I mentioned earlier, this minus cosec y can be written as cosec of minus y. So now you can write minus y as cosec inverse x. So I can write it as cosec inverse of x is equals to minus y. So now multiply both sides by again minus 1. So minus comes this side and this side will be left with y. So I can write y is equal to minus cosec inverse x. Now you replace your y. Y is what? Y is cosec inverse of minus x. So cosec inverse of minus x is equal to, it is minus cosec inverse x. So very easily you can prove this. Okay. Now we will have another bunch of 3 properties. So cos inverse of minus x is pi minus cos inverse x. Cot inverse of minus x is pi minus cot inverse x, and sec inverse of minus x is pi minus sec inverse x. Okay, so very easily you can prove this. Let's prove one by one. So here is first one, that is to prove cos inverse of minus x is pi minus cos inverse x. Okay, so consider this as y. Okay, so consider cos inverse of minus x is equal to y as usual, then minus x is equals to cos y. So x is equals to minus cos y. Now see here, as we in all the previous 3 properties we had minus, and minus sign was sign of minus, but in case of cos and cot and sec this is not true. We have another property, so you have to make use of this. So note down this. Cos of pi minus theta is, it is minus cos theta. Okay, so similarly in case of cot and sec. So cos of pi minus theta is minus cosec theta, that is minus cos theta. Similarly, this minus cos y can be replaced in terms of this cos of pi minus theta. So here theta stands for y. So I can write this minus cos y as cos of pi minus y. Okay, like this, how cos of pi minus theta is minus cos theta. So we have minus cos y here, and that is written in this form. Okay, now we can write pi minus y is equal to cos inverse. So what it becomes, cos inverse x is equal to pi minus y. Now you bring this or replace y is what? Y as, or you can write it as y is equal to pi minus cos inverse x. Bring this y this side and cos inverse this side. Okay, so replace your y. Y is what? Y is cos inverse of minus x. So replace here, you will get cos inverse of minus x is equal to pi minus cos inverse x. So very useful relation. So remember this, and we will be having problems on this property as well. Similarly, prove that cot inverse of minus x is equal to pi minus cot inverse x. Okay. As usual, take this as y. So consider cot inverse of minus x is equals to y. Then what minus x stands for? Minus x is equals to cot y. Okay. Multiply both sides by minus. So you will get x is equals to minus cot y. And again you have to use the property for minus cot. So minus cot can be written as cot of pi minus y. Okay, because remember that cot of pi minus theta is minus cot theta. So let me write that. You do this. Please do remember this. Make note of this. Cot of pi minus theta is minus cot theta. So that is why we have used that. Cot of pi minus y is nothing but minus cot y. Okay. Now we can write cot inverse x is equal to pi minus y. So bring this y this side and cot inverse x this side. So y is equal to pi minus cot inverse x. Bringing y this side to the left. Now you can write your or replace your y as this. Your y is what? Your y is cot inverse of minus x. So replace here. So cot inverse of minus x is pi minus cot inverse x. Okay. Let's have the third property. This. Sec inverse of minus x is pi minus cos inverse x. So as usual, take this sec inverse x as sec inverse minus x as y. Okay. Then minus x is equal to secant y. Okay. If you know, please proceed by pausing the video and check your answer at the end. Okay. So multiply by minus 1 on both sides. You will get x is equals to minus sec y, and minus sec a can be written as I told earlier, like in case of cos and cot. Note down this, sec of pi minus theta is equals to minus sec theta. Okay. So using this, I will write this minus sec as sec of pi minus y. So now transfer, or you can write it as sec inverse of x is equals to pi minus y, and y bring to the left. You will get y is equal to pi minus sec inverse of x. Bring this sec inverse to the right. Now finally you replace y as sec inverse of minus x. Okay. So this is your property number 3. So I hope you understood. Let's have another bunch of 3 properties, and very important one. They can be asked to prove in the final exam for 2 marks. Okay. So sin inverse x plus cos inverse x is always pi by 2 for all x belongings to this interval. Okay. So sin inverse x plus cos inverse x is pi by 2. Similarly, tan inverse x plus cot inverse x is also pi by 2, and sec inverse x plus cosec inverse x is pi by 2. You have to remember. Let's prove one by one. Okay. So to prove sin inverse x plus cos inverse x equals to pi by 2. So consider one of the term, that is either sin inverse or cos inverse, as a y. So I consider sin inverse x as y. So let sin inverse x equals to y. Then x is equals to sin y. Okay. And now you have to express sin in terms of cos. That is known to us in terms of allied angles. Okay. So we know that cos of pi by 2 minus theta means sin theta. So this sin is written as in terms of cos. Better you note down this. you note down this. Cos of pi by 2 minus theta is sin theta. Okay, so sin can be expressed in terms of cos, or cos can be expressed in terms of sin. So that is why this sin y is written in terms of cos. Okay, now you can write taking inverse on both sides. So we will get cos inverse of x equal to pi by 2 minus y. That is why you can say that transferring cos this side. That is cos inverse x equals to pi by 2 minus y. Now you can bring this y to the left. You will get y plus cos inverse x equals to pi by 2. And finally you replace your y. Y is what? Y is your sin inverse x. So substitute here. You will get required result. That is sin inverse x plus cos inverse x equals to pi by 2. Okay. So similarly you can prove next two results. So we will prove them. So here is the result that is to be proved. Tan inverse x plus cot inverse x equals to pi by 2. Okay. So take one of the term as a y. So let us consider tan inverse x equals to y. Then what x implies? X implies tan y. Okay. Now you have to replace this tan in terms of cot by using this property. Okay. So note down this. Cot of pi by 2 minus theta is equal to tan theta. Okay, so using this you can replace that tan in terms of cot. Okay, tan theta is in terms of cot means pi by 2 minus theta. So this tan is written in terms of cot means cot of pi by 2 minus y. Okay, now you can write cot inverse of x is equal to pi by 2 minus y. Okay, taking cot inverse on both sides. So cot inverse x equal to pi by 2 minus y. So now you can bring this y to the left. That becomes y plus cot inverse x equals to pi by 2. So replace y. Y is what? Tan inverse x. So tan inverse x replace. You will get tan inverse x plus cot inverse x is pi by 2. Okay, so very easily you can prove this. So better you remember this result as well. We will have one more, that is sec inverse x plus cosec inverse x equals to pi by 2. And if you know the way of proving, just pause the video and prove this. Your confidence will be high. Okay, so I will be proving it. Consider sec inverse x equals to y. As usual, x is equal to, it becomes sec y. Okay, now sec in terms of cos you have to write. So cos of pi by 2 minus theta means sec theta. So that is why I am writing this sec in terms of cosec. Okay, now you can write it as this, bring cosec this side means taking inverse. So cosec inverse of x equals to pi by 2 minus y. So bring this y to the left. It becomes y plus cosec inverse x equals to pi by 2. And replace your y. Y is what? Sec inverse. So sec inverse x plus cos inverse x is pi by 2. So this is all about few properties of inverse trigonometric functions. In the next session, I will be doing problems on these properties, and we will have much more properties to be discussed. Okay, so till then, take care and thanks for watching. And if you are new to the channel, then please don't forget to subscribe. Okay, so take care. We will meet in the next session.